Hello everyone. Today we are going to start signal flow graph. Signal flow graph is a graphical approach that helps us to draw um, or to get the overall transfer function of the system or overall gain of the system. Now we can get that from block diagram too, but in block diagram the process is tedious because we have to go through several steps to reduce the block diagram. And next, second thing is, if the block diagram is much complex, then it will be difficult to solve it. Rather, it will be easier to solve that by virtue of signal flow graph. Signal flow graph is actually involve a formula called Mason's gain formula, which generalize the approach and it becomes easier. So in this video we are going to learn how the signal we can able to draw signal flow graph from a set of linear equations. So suppose I have four sets of linear equations. So first I am writing the equations and then I am explaining how we can able to draw the signal flow graph by virtue of this equations. The first equation is x2. x2 is equal to a12 x1 plus a32 x3 plus a42 x4. So this is the first equation. Next is x3. x3 is equal to a2 3 x2. Next is x4. x4 is a24 x2 plus a34 x3 plus a44 x4. Okay. The last is x5. x5 is a25 x2 plus a45 x4. So these are four set of equations, and today we are going to learn how we can draw signal flow graph or SFG from these four sets of linear equations. We will know different terminologies associated with signal flow graph. Now first what I would like to say that these x2, x3, x4, x5 and x1, these we will call them the nodes of the signal flow graph. Okay, so we will draw them in form of nodes. So this x1, x2, x3, x4 and x5. These five are the nodes of the system. And the signals which is flowing from these nodes will be known as path gain. Okay, so this A12, A32, all are the gain of the different paths involving these five nodes. Now this first node is called input node or source node, and this last one is the output or sink node. Now this equation I am going to do. So what is this equation is actually telling that it is involving this node, it involves three other node along with several gain factors. Okay, so the first one is A12. Okay, so A1, A2. So the first, this will be the source node and this will be the sink node. So here A12 means I am going from node 1 to 2. So this will be A12. Now this A12 along with x1 is coming to x2. So this is the first component. The next is A32. Here what is the source node? 3. So this 3 to 2. So that means the direction of the arrow is from 3 towards 2. So this is A32. Now this is in conjunction with x3 coming to x2, and the third component, it is A4 so the A4 to 2, it is from source 4, it is coming to the sink x2, so this will be like this A4 2. Okay, so now we have drawn the first part. The next is x3. What is x3? It is only involving node x2, and this is from 2 to 3. So this will from 2 to 3. So this will be from node 2 to node 3. So what is the path gain? The path gain is A23. Okay, so we have done this also. Next come to the third equation. Here x4 apart is A24 x2. That means I have to go from node 2 towards 4. So from 2 towards 4. So this is A24. Next is A34 x3. So from x3 I have to go from 3 to 4. So this will be like the gain is A34. Next is A44. So what is A44? A44 means A44 x4. That means the node, it is coming from x4 node, and it is coming out from x4 node, and it is also coming into the x4 node. So this will create this type of thing. This is called self loop. Okay, so A44 loop gain is the gain. A44 is the path gain of a self loop. Now the last equation, x5. What is x5? A25. So that means I have to draw this path. This will be A25, and another is A45. So it will be like this, A45. Okay, so this is a signal flow graph from these four sets of linear equations. Understood? Now these equations will give us the signal flow graph. Now here this x1 is the source node, x5 is the sink node, and A12, A23, A34, A45 is actually forming the path gain. This is called feed forward path. Next is A12, A25. This is also a path gain. Similarly, A12, A24 and A45. This is another feed forward path gain. Similarly, if I go for A3 to A2, this is the signal in the opposite direction of the source node to sink node. So these are the basically feedback paths. So A32 is the gain of a feedback path. Similarly, A42 is also gain of feedback path. And this A23 and 32 is consisting a loop gain. These two consisting a closed loop. Okay, so these A23 and A3 is forming a closed loop. Similarly, A23, A34 and A42 is composing another closed loop. And A44 is making a self loop. In this way, we can able to identify, and if we know Mission's gain formula, we can able to reduce these overall system, and we can able to get the overall gain of the systems. Understood? So here we learn something that how we can able to draw the signal flow graph if some linear equations are given, and we discussed about few terminologies of signal flow graph. Thank you.